Good morning, everyone. In today's class, we are going to see the algorithm, that is find as algorithm. The objective of find as algorithm is to find the most specific hypothesis for all positive samples present in the given dataset. Read the given problem. Imagine a dataset containing patient attributes and their diagnosed diseases. Here, the dataset what we are considering for our uh, lab exercise is medical diagnosis data set. Okay, and in this medical diagnosis data set, you have 5 numbers of samples and 4 number of attribute columns. So what we are going to do, we are going to apply finders algorithm, and this algorithm is used to learn symptom based rule for identifying specific disease. For example, using finders algorithm, I am going to discover the rule. What is the rule? What I have quoted here is a patient should have fever, cough, and difficulty breathing, and how much like to have pneumonia. Okay, so here I am going to find my label column is pneumonia. So I will consider only pneumonia samples. So according to my rule, okay, so I will consider only pneumonia samples for specific hypothesis. So I am going to apply the finders algorithm on the data set. I am going to check whether it is working for the above rule using the Python code. So here I have 5 samples of data and I have 4 number of attributes, and the last column, okay, the last column is the target attribute. And for fever attribute, you have 2 possibilities, yes or no. And for cough also you have 2 attributes, yes or no. And for difficulty breathing, you have 2 attributes, yes or no. And for diagnosed disease, the column diagnosed disease, you have 3 labels, that is pneumonia, common cold, and healthy. So the first step in finders algorithm is you have to initialize the hypothesis space to the pi value. Here you should not see while you are starting this finders algorithm. Okay, you have to define the hypothesis space. For defining the hypothesis space, you have to consider only the attributes. Okay, fever, cough, and difficulty breathing, and you should not consider the label attribute. So I'm here, I have only 3 attributes, so I'm given here 3 pi's. So the pi is a symbol that is used for denoting the empty set. So it means I'm going to initialize the hypothesis. So I'm given here the symbol pi. Okay, and most important thing is we should not include the label column in the initial hypothesis. Okay. Once we define the initial hypothesis, the next step is this algorithm. It iterate over the sample. First, it read the first sample of data. That is, in the first iteration, it reads the first sample, yes, yes, no, and pneumonia. So what is our rule? Our rule is the label should be pneumonia. So this algorithm, it will consider only the pneumonia samples and it will not consider the other samples, other labels. So in the first sample of data, the label is pneumonia. So initial hypothesis H0 will be changed to a new hypothesis H1. Okay, and we will hence we update the hypothesis. So it reads the first sample of data and check whether the label is pneumonia. Here the label is pneumonia, so it update the hypothesis, and the new hypothesis H1 will come as yes, yes, no. In the second iteration, it reads the second sample of data, and here the label, it checks the label. Here the label is not pneumonia, here the label is common cold. So it exclude reading the second sample of data and it would not update the hypothesis and keep the hypothesis H1 as it is, and it just rename the hypothesis, okay, H2. So H2 equal to yes, yes, no. In the third iteration, it reads the third sample of data and checks the label. Here it checks the label is pneumonia. So it reads the third sample of data and it tries to update, the algorithm tries to update the hypothesis. Here, while updating the hypothesis, it checks each and every attribute of H2 with each and every attribute of x3. First, it checks the first attribute of h2, that is yes, with the first attribute of x3, that is yes. So both the attributes are same. So in the new hypothesis h3, it will keep as it is the first attribute. Next, it reads the second attribute yes in h2 and the second attribute yes in x3. So both the attributes are same and it keeps the second attribute as it is in h3. Next, it reads the third attribute no in h2 and yes in x3. So it compares the two attributes, both are different. There is a mismatch in the third attribute, hence it replaces the third attribute with the symbol question mark. Usually if you find any mismatch, okay, then you have to use the symbol question mark. So this question mark is used to imply that it is unknown attribute. In the fourth iteration, it reads the fourth sample of data and checks the label. The fourth sample, the label is not pneumonia, here the label is healthy. Hence, the algorithm, it would not read the fourth sample of data x4 and it would not update the hypothesis also. So, it keep the hypothesis as it is and the new hypothesis h4 is SS question mark. Yeah, in the next fifth iteration, again in the fifth sample, the label is pneumonia. Here, the algorithm, it reads the fifth sample of data x5 and compare it with every other corresponding attribute in hypothesis h4. In this case, there is a mismatch in the third attribute between the symbol question mark and yes. So there is a mismatch. Okay, so we could not we have to write only the generalized attribute here. Between these attributes, two attributes, the most generalized attributes is question mark. So I'm including question mark. So I'm including the symbol question mark in my final hypothesis, that is h5 equal to yes question mark. Okay, for the given problem, that is for medical diagnosis problem, okay, the rule is we have to consider some criteria for the diagnosed disease pneumonia. So for the pneumonia disease, the most specific hypothesis that accurately fits is the hypothesis h5 equal to yes question mark. That's all.